Well, hi, good morning, and thanks for joining me here in my shop while I face another day with this radio. And today is February 27th. So I was in here the last couple days. Yesterday, anyway, didn't post any video of what I did. I spent a long time in here rummaging around. Finally took out this transformer. Oh my god, all the testing I did on it suggests it's fine. I went back to the radio. Hunted, and hunted. Would you believe my conclusion is there was an error made in the factory with this radio? You know, that's not a conclusion you can reach lightly. That's bizarre. You make a mistake in a radio, it doesn't work. It gets to the end of the line, it gets tested, they find it. And it's not this is just the chance of a radio coming out of a factory with an error is actually quite small. So what I want to do is I want to review and focus right on that potential error, and go through the process of discovering it again and proving it out. I'll do it on camera. I usually do everything live for the first time, which is kind of the fun of watching my videos, but this is going to be kind of a show and tell a little bit. And then I already hear my cat outside. Holy smokes already. Oh my gosh, Peanut. Okay, so the show's gonna have to wait a minute because I have to deal with my cat. Right, Peanut? That's right. Maybe just before I get going, I'm going to do a quick COVID update. Now, I think I did one of these on a video I didn't post the last couple of days. So the story here is no, I did post it. I remember now. Yes. So as you know, I'm in one of the areas, or the area in Canada for the UK COVID. 189 proven cases, hundreds more suspected in Barrie, the city a short distance from where I am here. The province of Ontario has decided to institute lockdowns. I prefer the term stay-at-home orders. We're pretty much under a stay-at-home order here in my house anyway, but that's what's happening. So the government has recognized the situation, is taking action in this area. Generally, COVID is going down in Canada, but in specific areas it's going up, and those are the areas with the variants in them. So anyway, that's unfortunate. Now, what about this radio? So, I think I said before the cat came and interrupted me that I suspect there's an error, a factory error made in this radio. Wow, that's pretty bold. How in heaven's name could you ever come up with that conclusion? I'm going to try to come up with it again. But it starts with me staring at the schematic. Quite concerned about the wires over here. Kind of wondering where that capacitor is right there. It's a 0.05 capacitor doing a very important job. See, it goes to ground there. Where is that capacitor? Because when I look in the back of the set here, I can see the capacitors I changed pretty quickly. There's not a lot of them, just a few of them. None of these are 0.05s. The only 0.05 that came out of this radio is this one. Bit of an odd one. This one was located right up on top here, right up in here. And if you look, maybe you can see there's the yellow replacement there. You can see it's going right to this terminal I'm touching. I believe that's wrong, and I believe that's responsible for the poor operation of the radio, coupled with trouble in this transformer. I really did break the wire on it at one point, so there was really two things going on at once. Let's prove this capacitor theory, because it is crackpot. I mean, what am I claiming? I'm claiming this radio came out of the factory with an error, was sold in a store, owned by somebody and operated with a defect in it that I would imagine would result in poor performance on the AM band, no performance on the middle shortwave band, and poor performance on the high shortwave band. You know, one of the things about poor performance of a radio, which in some cases just means reduced volume, you just turn it up louder with the volume control and voila, problem gone. Maybe that's what went on with this radio. I don't know. It's just a weird thing. So the way I'm going to do this is first I'm going to pick off a known location, which is right here. I know exactly where that is. I know where these two resistors are. I know where that point is. I'm going to clip my voltmeter lead there. These are the two resistors I just mentioned. This is the point I want to get on, right here. If we were to trace this very carefully, we would find it goes over here, meets up with each of these secondary coils, not this guy in the middle. These guys, these three. These are the three band, for the three bands. Negative, or this. So somewhere on this wire, from this resistor over to here, should be this capacitor. Now let's trace the wire. I'm going to use my ohm meter to trace it. Tangled up here. So early on, as the things got weirder and weirder with this radio, I began to say to myself, there's something really strangely wrong with it. This is what I found. My experience is when the radios really behave weird and it's just a head scratching thing going on, there's usually something really out of sorts in the radio. So we're going to start here. This connects to this black wire. This black wire winds its way all the way up to this terminal. There you can see the 0 on the meter. The black wire then runs from this terminal into the transformer, which I carefully set down here on this wire. So this wire actually comes out like this. It comes out and connects here. One of the wires going to that transformer is hooked up to the wire I'm tracing, trying to find the capacitor that is supposed to be on that wire, and I'm going to show you it isn't. That's what I think I'm going to do anyway. So let's go back here. 0. Follow this wire. Goes through the hole here. And we don't want to get this wrong. So first hole coming in from the edge. It's got 3 wires in it. Now it's going to be tricky for me to get this on camera, I think. Yes, some of this just may not get on camera directly. Goes through the hole and rises up. Let me just get my eyes on it here. Okay, rises up. Appeared to be coming here. There's a 0 there. From there, it goes over to this terminal. This is really important now. You've got to get a look at this. Because if this is wrong in this radio, this is wrong in a number of these radios. Who knows how many radios came out of their... Oh, for crying out loud. Came out of their operation. I can't get the camera much better position than that. So this black wire to this terminal, and there's the 0. Capacitor is on this terminal. No 0. So you say, well, that capacitor can't be the one on there because it's not hooked up. It's hooked up somewhere else. If you look at the schematic all day, there isn't another 0.05 capacitor in here. What is that capacitor hooked up to? So that's number one. Number one, can't find this capacitor connected to this line. Number 2, what is the capacitor connected to? So we will now trace down from the capacitor where it's connected. I mean, I did this 3 or 4 times yesterday. I was last evening actually. I was so blown away by this. I couldn't believe it. I kept coming back in and going, no, this just can't be. So we're now hooked up to the ungrounded end of that capacitor, right? The capacitor goes to ground. Oh my gosh, it's going to be true. It's going to be true. I've done hundreds of radios. I've never found one with an error in it like this. That must have come from the factory. So, oh, couldn't somebody else have done it? Well, if they're really good at soldering so they can make everything look original again, maybe. But I don't think that's what happened there. Okay, so we're on this brownish, kind of a brownish wire coming down through the hole where the capacitor lead comes down and ties to the chassis. And that's this hole here, and that's this wire right here. Pretty silent, aren't I? Why would I get a? I shouldn't get that 0. Okay, so something more is happening. Oh yes, I should get the 0. What am I talking about? Okay, hold on, just momentary confusion. I'm tracing the wire, so of course I get a 0. Is this the right wire? And we get onto it, and yes, it is. What is this? Here's the antenna lead coming in, and by the way, I got a whole new story about how this all works out here. I've actually learned how to connect an antenna to this radio. Wow, after how many hours of work on it? Boy, oh boy, oh boy. I'll talk about that in a moment. So this is the antenna supply, the long wire antenna supply, and when you work the switch here, it sends this connection, or whatever, to one of these 3 terminals. Each of these terminals has a brown wire on it. The brown wires come up to each of the 3 coils. The antenna signal, if I do this, is now connected here. This is hooked up to that capacitor, which goes to ground. So I have a 0.05 capacitor hooked up to the antenna to ground, only on this band. Do you remember how different it was as I moved? That middle band did something quite different from the other 2. Because here it would encounter the capacitor on the antenna. The other settings wouldn't. But the problem with the radio on the other settings is that capacitor is not where it needs to be, so the radio's operation is defective in the other settings too. Couple that with a broken wire in this transformer, and this radio just is a wild nutcase at that point. Throw in some weird, bizarre stuff. Holy smokes. This literally has been one of the most challenging radios I've ever done. So, because it appears to have a factory error in it. So what is supposed to be done? How could this error happen? You know what? This is really easy to understand how this could be done incorrectly. Picture yourself in a factory. Now look at the lights I've got in here, okay? That's not what's in a factory. Not back in 1940, whatever. Factories were poorly lit, working with clumsy equipment, clumsy soldering irons, everything. Okay, so when we look in here, I'm going to take this off. We can see this connection. We have a hard time seeing or accessing the one where the capacitor is supposed to be, as I have deduced here. It's very easy in this very tight area, assuming maybe people are looking from this direction. They will see this terminal, but they won't see the other one. There would be a tendency to make a connection to this one in error. Okay, so now I've really laid it on the line here, haven't I? So what I'm going to do is I'm going to move that capacitor. I have to put this coil back in. Unfortunately, that still remains a bit of a problem. But I'm going to restore the radio back, and we're going to see if this makes it work. It would be, if my theory is right, it'd be the first time this radio's ever worked. Holy smokes. Hard to believe. I don't believe it. And just a little further note. Okay, there's a chance I'm the one who made the mistake. I removed the capacitor and I reinstalled the one on the wrong terminal. I made the exact mistake I just described. But if I did, it would be quite obvious the wire that where the capacitor was would still be on the terminal here. There's no sign of it whatsoever. So I'm really sure I replaced this capacitor where it was originally. I'm really very sure. And yeah, I'm sure. Well, we're gonna find out. Hmm. I don't know. I don't think this is going to go. There we go. Lock washer. And the top nut. This looks too big. No, that's what's here. Okay. Okay, lock washer. Nut. Oh boy. There it goes. There we go. Jackpot. Oh, it didn't come out. And other nut is missing in action here. Phooey on that. That's my soldering iron laughing at me. Oh, look at that. And it went flying over here. So it sounded. Another day in Jim's shop. Oh, for crying out loud. Situation here. Okay, found the nut. There. Okay, another attempt. Just make sure I'm calm here. I'm a little excited there, didn't I? Calm down, Jim. Okay, just tightening in the can here. Good. three wires. I have 3 wires to solder, and then I have to deal with the grid cap. Okay, wires are connected. Now, what about the grid cap? So, as I have said, but maybe didn't go out on video, these grid caps are steel, and you can't really solder to them. So, but here's the remnants of the wire. I can solder to that. We don't want that much wire out there. To shorten this up, and just solder it onto there somehow. And take a fair bit of wire, kind of wrap it around, and then bring it into contact with these copper wires here. Just kind of solder the whole bundle up. I think that's the easiest and best approach here. So first we need to shorten it up just a wee bit. Expose a fair bit of wire. This wire has to be scraped here. I'm not using the finished fish knife. This is some kind of Luna, some kind of, let's say there. Nora, made in Sweden, Swedish. I'm using a Swedish fish knife. Here we are. Okay, now the concept here is kind of wrap around and then somehow get in contact with those end wires and then solder the whole thing up. Okay, so far so good. You know, I suppose you could force these things back open, stick another wire in, clamp them back down, and get away with that. You want to clean it all up pretty good first, but if I can solder here, I think it's the best result. Fair bit here to heat up. I'm pretty sure that's going to work. Guess we can own that. Oh, not really. Not really. I think it's good. A little ugly. Don't touch it. It's probably pretty hot still. Now, what's next is that capacitor. Moving that capacitor. If I'm lucky, there's enough lead here that I can get away with it. Or I'm going to have to cut that one out and put another one in, or do something to extend the lead just a little tiny bit. So I'm gonna, looks like I did a good job of wrapping the wire around it there. It's got to go over to this post here. Even if I unwrap it, there's not enough wire, I think, to reach over here. Yeah, maybe there is. Get right in behind here. You know what? I can nip it off. There's enough lead wire there to get to the other post. I don't believe it. I still don't believe what it is that appears to be the case here. That this was done wrong in the factory. Because if one was done wrong, you gotta wonder how many more were done wrong. This won't fit back there. Sure. Oh, it just makes it. solder to that. Is it all the way over? You can't see it, but there's some wires in there that are helping me. Yeah, that's pretty close. I think that's right up against it there. No, I don't think it is. The wires I thought were helping me were hurting. Get under and come around the other way. Push it down. Bring it up. Bingo. Let's try that right there. Just kind of tacked it on there. But you know, these aren't current carrying circuits. They're just need a little tiny contact there should do the trick. Now, how firm is it? How do you get in there? Push on it. Yeah, it's stuck. Good. So I'm going to turn this radio on, and there's a chance it's going to work for the first time in its life. It's also a chance I'm completely wrong about all this, and I've just increased the buggering up of the radio. We will find out as soon as I just put a few tools away here. Okay. Spin around, spin around. Capacitor done, that done, 3 wires soldered. I think we're ready. Put the solder away. A few more tools. Okay, have I delayed long enough? I think so. No reasons have come to mind to not do this. Okay, there we go. Volume down. Volume up just a little bit. Just double check quick. All seems well. Okay, so we're going through the dim bulbs. I'm going to drop this voltage a little bit. Go through the dim bulbs here. And good. Here we go. like I've been working on the power supply or anything like that. Okay, dim bulbs are doing the right thing. Let's crank this up to where it should be. Up there. Radio's eating 106 volts. Okay. Come on, man. Come on. Come on. Make some sound. I'm going up. I'm going. Well, there's some sound. Hey, no antenna hooked up. Never fully explained this antenna situation here. But I'm not going to. I'm going to carry on. Connect an antenna. Now this guy's not hooked up. Ouch, the switch is not thrown. I'm going to put this onto the antenna. Listen to that. Okay, volume down. Volume up. Well, it was good there with my hand. Let's take this off. There we are. We're cooking. Okay, so just before I find out that this really didn't work, it seems to have worked. So, round of applause. Happiness, thumbs up. Band change. That's broadcast. That's pretty quiet. That's pretty quiet. Could have to do with this. I do not have the... So on the top band, you need to close this if you're going to utilize this long wire antenna. Top band, I'll just do it with a screwdriver. Don't use my finger. Well, there's a little bit of a buzz there. Remember, the alignment of this radio could be just something horrendous at this point. Okay. So, antenna. This is great. What goes on with the antenna? So, when you look in the book here, look at this, look in the book. Here's the three terminals, A, D, and G. And I've always thought, and there's the link, you pull the link off, and then you stick your dipole antenna where the link was. No. No. You pull the link out, and you hook up the antenna between the A and the D, the antenna and the dipole antenna terminals. That's why they constrained, or they twisted this diagram to show this wire coming up and looping around in a funny way, to get the D close to the A, so people like me would be aware that that's where you hook up the antenna. Hooking up a dipole between the D and the ground really doesn't make a lot of sense. It doesn't make any sense, in fact. The interesting thing is, if you're going to use a long wire antenna on A, you must have the link closed for the highest band to work. The rest of the radio will work. Just to get the highest band to work on a long wire antenna, that link has to be in place. So we're hooked up to A right now. And there's lots of alignment issues, but we're hearing stuff. Let's see if we can pick up a station. Then I'm gonna go throw the switch on this antenna, so we have as much antenna as we can. Let me turn this down a little bit here. Okay. The switch is thrown, so we are hooked up on one wire anyway to outdoor antenna. We're running with only 88 volts. Let's give it the full shot. That could be why the volume is so low. And we're running with 115. Good. Yep, I got more volume. Sounds a little better. So where I live, stations can be picked up down in this area. And there's a French one up here. If we get the French one, oh yeah, it's working. Okay, reliable to get something here. Something in this area. Hey, there it is. Despite all the funny noises and that's just antenna crap. Okay, we got the radio to work. Did we really? This is just really, really shocking to me. If a radio with a factory defect, you know, it's 2021 and the defect was made in what, 1941 or whenever this radio was built, and it's gone all the way until it reached me. Wait a minute, he still might be talking too soon. Okay, so we're gonna feed in. I should close the link. I need to close the link. This is too high, too high, too high, too high, too high, too high. I'm gonna close the link here. I can't bear to put my fingers across the open link. Doing that essentially supplies a ground for the high shortwave band secondary coil. Without the ground, the coil is open circuit basically, and so you can't get a signal out of that coil and up to the grid. You close this, it applies a ground. The other two bands the coils are grounded all the time. That help anybody? I don't think so. What are we trying to do? We're trying to feed in this guy. We're going to go up a band. Okay, so I think we're on this band. We'll dial up around 3. Let's go up around 3 megahertz. Okay, 3 megahertz. Up here, 3.5. Give it a chance. So we're 3.2. This band's working. Now the high band. The link is in. Without the link, you cannot use this extension wire. This long wire type approach. Okay, we happen to be tuned to around just above 10. Okay, let's see what's there. There it is. By gory gosh, the radio is working. Oh my gosh, I can't believe it. I can believe it, but I can't. I can and I can't. Wow. That's really quite a journey there. Quite a journey to get to here. Look at that. So I'd be smart and I'd stop now and work on all this video I've collected and see what I can put together to make for an interesting video of how I got to here. That's a shocker. A radio with a manufacturing defect in it that hobbled this radio right up until today. Wow. It's just, I can't believe it. Well, through the wonders of video, it's the next day. I'm in here again. I just produced the video that you've just watched up to this point, and in that video I said over and over and over, I can't believe it, I can't believe it, I can't believe there's a factory error in this radio. So I came in here and looked very, very carefully at it, and it's my error. Yes, I'm the guy who made the mistake. This radio came out of the factory just fine. I'm going to take a few minutes now, because I'm always interested if I make a mistake like this. Like, it wastes a lot of my time and stuff like that. I don't want to make these kinds of mistakes, and I'm trying to do everything I can to avoid this exact kind of mistake. Yet I made one. How did that happen? So I'm going to do a little accident analysis here. I'm going to start out by showing an earlier video that takes a camera shot right up here and you can see the capacitor. Here's the capacitor. I dug it out of the garbage can the other day to look at it again. You know, this is a strange capacitor. It's not round, it's kind of rectangular. Why exactly they would make one rectangular on purpose, I don't know. This one is denoted as a special capacitor in the schematic. It's called a low loss capacitor. Well, my impression is certainly all modern capacitors, you know, of this kind of sort, like the kind I'm using to install, they're all low loss. I don't know that any of them have any losses in them. But there's something even more interesting about this capacitor. Well, let's go to that piece of film for a moment, and then when we're back live here, as live as my videos ever are, I'll talk a little more about it. Okay, let's see if we can focus our way down to the area of interest. It's just too far away to really see what they've done. What have they done with that little capacitor? Suppose I could try to identify it on the schematic and then figure out if the lead is going to ground. Where is it? It's totally out of view behind the coil. Can't get through here. Can't look from over there. Hey, this is a dumb situation. 0.05. So I'm going to try to find this on the schematic, and I suspect it's soldered right there, soldered right there. I don't know. Okay, so you've seen how this was positioned very vertically in this radio here. This raises an issue for me. The way I installed the capacitor is the cheap, easy, fast way to do it. You can see the little yellow corner there. That's left it on an angle. When this was in, this was placed perfectly vertical, right below this terminal here, which is why I thought this was the terminal that had it on it, because it came right up to it. But the fact is, I almost fell over when I saw this. I almost fall over a lot. So if you look really hard back here, the remnants of the lead wire is here. There it is. I'm poking out. Maybe you can't see it there. It's a black wire. You can see it above the capacitor. That's the lead wire that came over just under this terminal and picked up the capacitor, that rectangular capacitor. I guess when I reached in with my cutters, you know, when I'm looking from here, I cannot see that at all. I swear the capacitor is tied to this terminal. And I reached in with my cutters from here, and when I cut it, I thought I was cutting a wire off this terminal. I was sure of it. I had all the sensations of doing that, but in fact I was cutting a lead wire that was coming over here. Now the question is, why did they do that? Why didn't they put it in on an angle like me? Why did they put it in vertically? Why did they use this unusual capacitor? Why is there a special note in the schematic? What's going on with this thing? Now, I've put mine in differently. You know, there's a basic rule here. Return everything back exactly as it was. Run the wires exactly as they ran. Because you never know just where there's a critical situation with the exact location of a component. So what I'm going to do, I'm going to leave it that way. And I'm going to carry on with the radio because I'm pretty sure it's going to work fine. Pretty sure. We'll know after the alignment is done, but at this point, I I don't think I want to go in and try to fool with that. I mean, it's not a rectangular, there's nothing special about this capacitor. One thing about these is, you know, they're basically a sandwich, right? Two could be could be aluminized paper, but let's not worry about that. Just think about the structure. There's two pieces of conductive aluminum with a piece of paper in between, and then that thing is rolled up and stuffed into a container or covered in plastic or whatever it is anyway. The result of that is one of those sheets ends up coming around the outside. There's an outside sheet. The other end's connected to one end here, and the other one is connected to the other end, but it's actually inside the first layer of this outside sheet that might be connected here. And a lot of capacitors mark the outside sheet or foil. Now this black line is marking which lead is connected to the outside foil. Now, shame on me, I pay little attention to this. The capacitors I buy don't have the outside marked, although you can figure it out pretty simply with some simple tests. You can kind of get a grip on which lead is connected to the outside foil. Is that part of the picture here, that they were trying to do something? What would they do? Now, I can't remember which way this was installed. I do remember now. I cut the top here, and then I ripped this out in the long run, just ripped it out. This was the bottom. So they had the outside foil connected to the chassis, or grounded. And that's typically what you do. You hook up the outside foil to a low impedance part of the circuit, so the low impedance part is on the outside. And so if there's any interference and stuff like that, it's encountering a low impedance circuit, and chances are it can't produce any effect. In a high impedance circuit, it's very sensitive to tiny influences. So if you did this the other way around, you've installed it this way. Now the outside foil is a little like an antenna sitting out here, a little like that. And if it's hooked up to high impedance, small influences can cause big effects in the radio. So potentially I hadn't finished boobing this up. Still more boobing to do. I'm in the middle of a boobing. But you know, what could this really do? You'd be laying up the grounded outside foil against this coil. I have no idea. No idea. Be really interesting to meet up with the person who designed this, or someone who worked in the factory and built these things, and say to them, oh, why did you do this and why did you do that? I don't think I'm going to meet any of those people. There we go. So what to do now? So I think we're getting close to an hour here of video. What would be interesting to do in the next few 10 minutes or so? I think I can verify the alignment and work on the alignment of the IF and get that out of the way. We're going to find out, if you remember, I couldn't generate a peak in one of these two screws here, and that was no doubt because of the screwage that was going on in the radio over here. Now we should be able to get a peak. And something else that's just a little interesting. Why did these cans have red X's on them? I've been wondering that the whole time. Why did they put a red X on there? A red check mark would be nicer. No idea. Maybe the guy who's doing the alignment X's them off as he did them or something in the factory. I don't know. Maybe once they did an alignment, they put an X on it. Or who knows? We could guess anything. Okay, I'll get set up to do the alignment, the IF alignment. Okay, I think we're just about ready to go. Let's see, I've got the signal generator at 4. It should be on this. Should say 455. Should be running at 456, which is what is stamped on the back of the chassis. I've got a capacitor ready to inject the signal in the grid of the IF tube. Here we are. Signal level low. Radio's not on yet though. Let's get the radio on before we get too far gone here. Okay, through the dim bulbs. looks good. Okay, we got full power. Set the line voltage. 116. Go just a touch higher. Okay, not that this the line voltage should be able to fluctuate and the radio not show any variation in its operation. We need our output meter on. We're not hearing too much yet. And we have no antenna connected, so I will be the antenna. Oh. That's not very reassuring. Let's carry on with what I'm intent on doing. But I really would kind of expect that to make a lot of noise. Not to worry. Okay, so we're going to hook this up. We should hear a tone coming to the speaker right away. There we go. Give it a little more juice here. That might be just a little bit too much. Yeah, my signal generator output varies wildly from band to band on my signal generator here. So I'm calibrating it now. It's good. So what's here now should be, I can, you know what, I can control the volume with the volume. But I'm supposed to leave it up all the way. Didn't I say that? I'll turn it down a little bit just now. Okay, forgot what I was going to say, so it can't matter too much. Let's carry on here. So the signal is only passing through this transformer. I've injected it after this one. So, you know, the signal coming, you can actually see it in this radio. From the antenna into this tube, through the tube, into here, out of here, into here, out of here, into here, out of here, over to here. So feeding in here, it's going through here, coming out onto the speaker. This one I already lined. I'm using a screwdriver for. I'll use something a little more. A little more. A little less, actually, a little less metal. Okay. Turn the radio up. We're not seeing it here. Okay, I want to verify that the meter is not wonky. This meter can be wonky. Looks wonky to me. That's more steady. It's definitely the tone. Okay, away we go. Oh! I looked away and I looked back. It's gone full. What happened there? Who's acting up? Ooh. What's with the big jumps there? Okay, so there's, I'm tensioning the screwdriver, but it's not turning the screw. So I'm going to get the screw snappy thing happening here. Oh, that was nice and smooth. I'll take that back. Let's go this way. Yeah, so I think it was right on the money. It looks like the highest I can get it is to around the -6 area there. This is not the transformer that's messed up. Ooh, you know. So that little jump there is from using an unstiff tool. I'm going to get a great big screwdriver here. First we'll check for sensitivity. Lots. And use a smaller, less metal screwdriver. See if we can get away with it. No. Sometimes you can. This time we can't. Okay, try and get a stiffer tool here. I didn't even read the instructions. Hey, come on, meter. So when I had this apart the other day to fix the meter movement, I noticed that the switch in here is completely boxed in inside a can. It's not easy to access, so I thought I'd clean that switch, but I guess I never really have. Did you hear it go right by? Okay, so we're up around 7 now, minus 5 rather. Okay, good. Now we'll do this one. Turn this down. Expectation is putting the signal in here, it goes through an amplifier, so I don't need as much going in. Take that off. Stick it on. I can attach it up here. Actually, it's a little bit of an easier spot to get at. Somebody's producing an awful lot of heat here. Oh, this tube is unbelievably hot. 133 degrees. 165 degrees C. 107. Every time I do it, it's hotter. 173. Oh my gosh, that's just crazy hot. That's not a good sign there. That's crazy hot. Are they supposed to get that hot? That's going to start burning pieces of paper on it and stuff like that. Wow. Okay, well that is a worry, but that's a little bit down the line. Let's carry on here. What I was doing. Right. I'm going to put this here. And when I could feel the heat. So output tubes and rectifier tubes are hot. But that just seems nutsy. I can feel it this far away. Oh my gosh, there's got to be something going wrong there. Well, before it burns up, let's see if we can get it working. Make it work. Hey, I didn't hear a thing. We should hear it. But this is probably way out. I'm going to turn up the signal. Wow, we still don't hear it. That's not very reassuring at all. Okay, we'll go up another notch here. Okay, I can hear it. Okay. Come on, coil. Come back to life. Oh, that's a bad sign. So I just put pressure on this and the tone increased. It went boop. I didn't even turn the screw. This is bad, bad. Bad, 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 bad. Bad. Oh my gosh, I must have tightened that screw down when I was experimenting with it. Well, there's a pretty clear peak there. Okay, other one. There was a lot missing here. Turn it down that way. Okay, back to the first one here. First. So they're both generating a peak now normally. Remember at first this one of them wouldn't generate a peak. And that's probably because the Okay. Could be something external to the transformer. Could be this connection. Thank God it is. I think it is. Yeah, this is crap. Wow. Let's get it on there a little bit. I have to do something more muscular with the situation here. Come on, just connect for now. A little bit. That's good. Get this close anyway. Oh, you see the whole thing jump there? And I think it went off. Stay on enough. Some of you might be saying, you can't align a radio with a loose connection like that. You're absolutely right. Let's do it now. Is it this? It is. Either one of these screws moves this wire ever so slightly. Fools with this connection. Okay, but the thing is we have it aligned. We have it aligned. I think it's time to play this radio and find out what goes on. Just turn down the volume. This could be a dramatically different radio at this point, even though I haven't aligned the rest of it. Okay, so antenna. This is the moment here. Why doesn't it make noise? Set the volume rate down. Oh, barely turned it up. Still didn't read those instructions, did I? Took the time to put them on the screen so I could, very clearly ignore them. Let's go tuning. Oh, this sounds good. Come on, Frenchie. Voila. La French station. It's another indication I should not try to speak French. I don't mean to insult people. Well, that's not bad, that's not bad. And it's right where it should be. 840. It's right near where it should be. Let's go see what else we can get here. 740. No. 680. Okay, so I think that's 680. 640. Wow, 640 is wiped out by that noise there. Good strong station at 590. Well, you can see the volume effect here yourself. That's the end of it, right there. So, wow, lots of volume. No wonder that output tube is so hot. And how hot is it still? Is it getting even hotter? 156 degrees. That is one hot tube. Okay, I think that's it for today. I think that's pretty good. That's for today and yesterday, actually. And now I've managed to repair all the mistakes I made along the way, except for this last one. Not my mistake, but needs a repair. We'll complete the alignment tomorrow on the radio, and then we'll see what its real performance is like. So thanks a lot for watching, and have a great day.